Welcome, ladies and gentlemen, after the lunch break. Oh, stay here if you want. I have a special guest today. He is from Agfa. You might know Agfa from your camera in former times, so do I. And I'm curious what Agfa presents for nowadays. And it's about Zirfon. Zirfon, Agfa's contribution to the H2 economy. Give him an applause, Mr. Oh, glasses, Nick Valckx. Sorry.
Yes, hello, good afternoon, everybody. So I will briefly sketch a bit of what Agfa is doing and also what's its contribution towards the hydrogen economy, which is mainly our Zirfon. Agfa, I think, is especially also in Germany pretty known. We were founded in 1867 from Agfa together with Agfa-Gevaert. I think also known for the graphical industry, for the inkjet. But the reason why we are here is for the introduction of Zirfon on the electrolyzer market in 2007. Briefly, Agfa, we have the offset solutions, which is graphical plates, also the software related to that. For example, the PDF format, everybody knows it. It was the software from Agfa in the past. We have the radiology solutions, which is still digital X-ray films, analog X-ray films. Healthcare IT, which is part of software interlinking hospitals, for example. And then we have inkjet, wide format printers up to 4 meter. Also the inks, again the software, but also related to PCB materials. The P-dot, which is maybe known for you guys, is also from Agfa. And the part where we are here for is for Zirfon. So part of your daily life, but not always visible. Now, why are we on the hydrogen fair? It's because of Zirfon, and Zirfon is basically a membrane developed for alkaline electrolysis. And we are indeed just a membrane seller, but we capture quite a big market share within the alkaline community. And we are trying our best also to make sure that the whole community knows what our value is in this chain. So alkaline electrolysis, we can either be used in an atmospheric or in a pressurized stack. You have the Zirfon separator in between, which is more or less 80% ceramic membrane of zirconium oxide together with 20% polysulfone. The conductivity of the membrane you get through a porous structure and a 30% KOH at high temperature. And independently of, for example, an atmospheric stack or pressurized stack, the material can be used. Now, what's the reason for our success? We have this support layer in between, a PPS mesh, which gives you the strength and the durability. And on both sides, we have a symmetrically coated zirconium oxide paste. We call it a white toothpaste, which is in there. And then there is a solvent exchange process, which makes this type of membranes. And you see the dense skins on the membrane. This creates a bubble point, which means that if you have a gas which needs to go through, you need to put a certain pressure on the membrane in order to get it through the membrane on one side. And at the same point, you have it on the other side as well. So even if you succeed of getting a bubble through on one side, you still have to do it on the other side as well, which in the end results in high purity of the gases. And at the same time, it's porous, so you get high ionic conductivity, so a low ohmic resistance. So typically, a Chinese stack would go up to 4 amps per square 0.4 amps per square centimeter. We can go up to 2 amps per square centimeter. So really entering the PEM territory. And that's also what we have announced last year, where we launched the UTP 220, which is a thinner membrane. Our standard is 500 micrometer thick, but we have developed a thinner one over the last 6 years. But it's only commercially available since last year. And what we've done there is basically we have gone up in current densities. So the data you see here are PGM-free. So what you see here is a 10 by 10 centimeter stack, just standard radii nickel electrodes. Where we have put a current density of 2 amps per square centimeter over there, and there you end up with a voltage below 1.9. So we are reaching a PEM territory as a stack, but with the cost of an alkaline. So we don't call it a traditional or an alkaline electrolyzer anymore, we call it already an advanced alkaline electrolyzer. And that's really the reason, one of the reasons of our success is really because we can go this high in current densities and still obtain good gas purities. We have several stacks which are directly linked to renewable energies, so also there alkaline can clearly cover up for that. That's because of this bubble point that we have. so you have no more impurities of the gases. And at the same time, you can really go high in current densities. I think we have shown that this is reachable. Our customers are not there yet. They are testing this all, and they probably will go higher in current densities. But I'm pretty sure that in the near future, we'll see stacks popping up higher than 1 amp per square centimeter. Now, at the same time, we've also started to be a bit of the cost of hydrogen. And there you see that we have done some typical CapEx versus OpEx cooperation. We have a booth over here. I will briefly show this here, but feel sure to come over at booth C21 to discuss this further. But the data we've used here are from the ISPT study of the Hydro Hub. And at the same time, we've taken into account the 50% running hours a year, a cost of €50 per megawatt hour for the green electricity. And what you see here is the impact of Zirfon directly on your cost of hydrogen. So it's, but we're definitely open to discuss this further and just make the statement here. But what we are showing basically is that if you decide to move forward with alkaline and you tend to move forward to higher current densities, we can clearly work on the operational cost, and at the same time we can also work at the capex, which in the end will result in a green hydrogen cost which is more or less related to what you currently pay for your grey hydrogen. So we are showing actually that it's doable to come at the same cost. So market-wise, we have sales forces in China, Japan, South Korea, and Europe. I think we are recognized currently on the market as the best in class. We also want to stay that way. Also, our research team is over here, so feel free to come by and discuss with them. We are ready for volume. We have 1 gigawatt in 1 shift a year, and we have made already clear the intentions to move forward for extra volume in the next couple of years. So in the end, we started with Agfa as a camera company for photographic film, and I hope by the end of this you have seen that we can also contribute towards the hydrogen economy. Thanks.
Yeah, thanks a lot. And if there are questions from the audience, please take the chance. Take some time to think whatever you want